Hello everyone, we're Team 31 and we're working on the wheelchair step lift system for our client, Dr. Kim Anderson. Our goal is to provide a wheelchair lift that also converts to stairs when it's not in use. This project was handed down from last semester, and here you can see what our current prototype looks like. We have 4 linear actuators that raise and lower our platform. So far, our biggest challenge has been figuring out how to control the actuators independently. Some other problems we're currently facing are adding a safety feature to prevent rollback and also the overall stability of the system, which Nick will go into further detail about next.
The following model shows the project that we inherited from last semester's group as well as the design changes we are proposing. So anything in gray or gold that you see is what we currently have and what we received from last group. Everything in red is what we are proposing to add. So while this system that the last group had does work as a lifting mechanism by actuators running through these 4 holes, there was no stability with it because it would just rest in the center and it would want to tilt one way or the other. So the biggest problem that we attacked is adding enough stability to the system. So we did this by adding a large plate to sit underneath it that covers everything and has 3/4 inch rails welded to it that these bearings right here will run through to guide the system as the actuators lift it up and down. So we can show this real quick in the up position, what it will look like. This is 20 inches off the ground, and then also in step form.
Right now, we are currently working on stress calculations and obtaining a factor of safety for our design. After confirming the safety of our design, we will go ahead and assemble, then move to the controls aspect. Our first option is controlling with an Arduino, but we are worried about the safety and reliability with our limited controls experience. Our second option would to be buy a separate control box, but user interface would be very difficult and isn't the best option. Another small issue we found was when zeroing the actuators, they all fall out of place, which will not work. The solution for this is to 3D print a small guide shown so they can no longer move when fully extracted.
So I will be talking to you all about our budget and where we are at with it. The first item we have is machining and fabrication of a stability system. And Nick actually went out and got us a quote for this, which is going to cost about $119 and will take about 1 to 2 weeks. The second item we have are bearings, which will cost about $213.36. Then this will take about a week. The third item we have is a control box, which will cost about $200 and will take about 1 week. The fourth item we have is a controller, and this will cost about $100 and take about 1 week. The final item we have is the safety feature, which will cost about $50 and will take about 1 to 2 weeks to get that in. Overall, we're looking at about $682.36. Thank you.